Okay, good day everyone. We will be talking today about this part 2 of troubleshooting. So actually in every problem there are many or there are several possible causes or causes that is the cause of the trouble. But in our discussions or in our slides we will only tackle one at a time. So maybe in one problem, just one um, a cause, one effect, one solution. So, um, but but when you will have the experience on board, surely you will understand that every trouble has several causes. So now we will start this slide. So, so if the cooling water flow through after cooler is interrupted, the power output of a turbocharged diesel engine will drop so because the density of the air will decrease. So pag nawalan tayo ng cooling water sa ating turbocharger, sa ating after cooler, so or charge air cooler, so pag nawalan tayo ng cooling water sa ating charge air cooler, so init, wala na magpapalamig sa ating charge air, di ba? So, pag hindi natin napalamig, so mas maliit lang yung volume or density na pwede mo ipasok sa ating combustion chamber pag ganun. So, when the water flow through the after cooler is interrupted, the air temperature increases. Automatically, the volume of the air increases and the density decreases. Hence, for the same said volume, the quantity of the air from the point of view of weight as concerned will be always less than what it would be if the temperature was lower. Higher the temperature, the weight of the air reduces. When the weight of the air reduces, the fuel injected will not burn efficiently. Hence, there is automatically a drop in the power output of the engine. Okay, so question number 2. So operating a propulsion diesel engine at less than 30% of designed normal load for prolonged periods will result in it will result in carbon formation in the combustion chamber surfaces. So when an engine is operated at such low loads, the turbocharger efficiency drops. When the turbocharger efficiency drops, less quantity of air is supplied to the cylinder. Hence, the quantity of air available in the cylinder for combustion is reduced. This will automatically reduce the quantity of fuel which is burnt. At the same time, the fuel will not burn efficiently. Thus, unburned fuel will lead to carbon formation and the combustion chamber surfaces will get coated with the carbon deposits. Next, diesel engine fuel oil contamination often results in fuel injection system malfunction. So the fuel oil of diesel engine will get contaminated with water or with solid particles such as silica, rust, or alumina. All these three components will result in improper functioning of the fuel combustion injection equipments. Because of the water, there will be rusting and lots of misfiring in the combustion stroke. Also, if there is a hard particle, silica or alumina present, then it will give abrasion of the needle and guide and cause the leakage of fuel. Any catalyst implies entering the clearance spaces of part of fuel injection equipment. Can lead to accelerated wear of these parts. The wear may be extensive with few days of operation with contaminated fuel. Also, it will block the injection holes of the nozzle and cause complete malfunctioning of the fuel injection system. Okay, next. Operating a diesel engine under light load and at lower temperatures for extended period can result in. So the answer is a formation of carbon in the inlet and exhaust valve. So this is the same with um, almost the same with the previous question. Next, which of the conditions listed occurring in the diesel engine would cause carbon deposits to develop in the piston ring belt? So, all of the above: faulty combustion, excessive ring temperature, over lubrication. So the carbon deposits develops in the piston ring belt because of improper combustion, number one. So the improper combustion of fuel results in carbon being deposited. Two, excessive ring temperature. If ring temperature are excessive, then lubricating oil will get burnt, which also leads to the formation of carbon. So number three, over lubrication. So the excessive lubricating oil that is supplied to the piston ring will get burnt and convert into ash or carbon, thus forming the excessive coating of the carbon on the ring. Okay, next. If a crankcase explosion occurs in a diesel engine, which of the listed actions should be taken? Okay, so we should allow the engine to cool before opening the crankcase. So that's the most important thing to do. So there will be two kinds of crankcase explosion. One, a primary explosion, and other, the secondary explosion. When the primary explosion takes place because of the oil mist and the appearance of hot spot in the crankcase, there is a high pressure rise in the crankcase, which is released into the engine room atmosphere with the help of crankcase relief valves. At the same time, the non-return valve will shut and not allow the new air to enter into the crankcase. The crankcase atmosphere will be highly rich and hence there is a less possibility of exposure. Under such circumstances, if by mistake the crankcase door is opened, fresh air will enter the crankcase and bring the crankcase atmosphere in the range of explosive limit. When this happens, there will be heavy explosion and a secondary explosion may take place. So the best thing to do is to allow the engine to cool down before opening the crankcase doors. Okay, next. The burning of fuel oil in a diesel engine having a high sodium content will cause, so saan ba natin nakukuha ang sodium? So usually, pag yung ating fuel is may mixture siya ng seawater, so magkakaroon siya ng high sodium content. And then usually naman, yung sodium will be removed through centrifuging naman. So when we use the centrifugal purifier or through centrifuging, so the sodium will be removed from the fuel oil. So as long as your purifier is running smoothly and running in good condition, so there you will have no problem with sodium content. But if ever that your purifier will not run smoothly or there is a problem in your purifier, then high sodium content in your fuel may occur. So high sodium content will cause corrosion and grooving of exhaust valves. So in general, fuels leaving the refinery have sodium content well below 50 milligrams per kilogram. If the sodium content increases, which is normally caused due to seawater contamination, a 1% seawater contamination represents potentially a 100 milligram per kilogram increase. Vanadium is also present in the fuel oil, which combines with oxygen to form vanadium pentoxide, which combines with sodium to form sodium-vanadium complexes. It is well known that there are low melting temperatures of sodium-vanadium complexes of certain critical ratios. The most critical sodium-vanadium ratio is about 1:3. This will form a sodium-vanadium complex with a low melting point, which will flow with the exhaust gases. It will get deposited as a hard and brittle layer on the cold surfaces such as exhaust valve spindles, turbocharger nozzles, and turbine blades. This layer is highly corrosive and corrodes the metal. It is also brittle and breaks away, exposing the metal for fresh attack, especially when they get deposited on exhaust valve seats. The hard layer breaks and gives a cutting effect on the seat. Preventive measures can be taken, such as keeping the temperature of the exhaust below the melting point of vanadium oxide, pentoxide, and removal of sodium by proper purification and proper draining of the settling tanks. Therefore, high sodium content in the fuel oil will result in corrosion and grooving of exhaust valves. Also, when you drain tanks, especially settling tanks, when you drain the tank, seawater will usually go down. So if you drain the tank, seawater will get go out first before your fuel. So it is also important to have a regular draining of our tanks to prevent high sodium content, and other unusable mga elements. So pwede natin i-drain. Okay? Next, the longer the ignition delay period resulting from improper use of low cetane fuel, the the more rapid the rise in the combustion pressure. So the longer the period of ignition delay, more quantity of fuel will accumulate before the actual firing will take place. As a result, there will be sudden increase in the combustion pressure. When the large quantity of accumulated fuel ignites, there is a sudden development of the high pressure wave. At the same time, if the ignition delay is too much, there will be afterburning. When afterburning takes place, there will be high and forced temperature in your combustion chamber. Okay. Next, if the relief valve of the diesel engine cylinder lifts, the cause could be, okay, there are many causes, but one of the causes will be liquid in the cylinder. So when there is a liquid in the cylinder, the piston moves upward. Hydraulic pressure will develop because of the presence of liquid. As liquid is incompressible, large amount of hydraulic pressure is developed. In order to save the engine components from damage, the relief valve will lift and release the pressure. So that's how important relief valve is in our cylinders. Next, the substantial increase in the crankcase pressure could be an indication of a worn cylinder liner. So there's a possibility of a worn cylinder liner. So when the pressure in the crankcase of diesel engine increases, it could indicate blow past by the piston or blow by. This could be due to worn out cylinder liner, or the piston rings are leaking, or piston rings are broken. In that case, large amount of high pressure gas will enter into the crankcase and produce high pressure in a crankcase. Hence, the substantial increase in the crankcase pressure could be an indication of a worn out cylinder liner. Next, an indication of an overloaded main propulsion engine. So there are many questions about this on our previous video. So now here's another answer. So high exhaust pyrometer readings. So as a general rule, the exhaust temperature is related with the load of the engine. The higher the load, the higher the exhaust temperature of the engine. Hence, it is the direct indication of the load on the engine. If the exhaust temperature is higher, then the engine is overloaded. So, paano malalaman na nag-overload yung main propulsion engine mo? So, check mo lang yung high exhaust temperature mo. Baka mataas na yung exhaust temperature mo, may problem na, baka overloaded na yung main engine mo. And after that, you should check the ways to remove those overload. Okay. Next, the dry type exhaust silencer clogged with soot will cause loss of engine power. So when the dry type exhaust gas silencer gets clogged with soot, there will be a large amount of exhaust gas to flow, and because of that, the exhaust gas pressure will be higher. The complete removal of exhaust gas will not be possible which will cause the mixing of the exhaust gas with the incoming air. Thus, it dilutes the incoming air with the exhaust gas. This will cause improper combustion because of the starvation of the oxygen for the combustion of fuel. The exhaust temperatures will increase and consequently there will be loss of power in the engine. Next, the color of the exhaust from the diesel engine should be A. Clear. So the clear color of the exhaust gas from the engine exhaust will indicate the best possible combustion without any carryover of the fuel, lubricating oil, water in the fuel, or improper combustion. So it should be noted that the color of the exhaust indicates the health of the engine or any defects in the combustion. If the color of the exhaust is black, it indicates improper combustion that may be due to some fuel system malfunctions or an overloaded engine. If the color of the exhaust is white, is cons- it consists of water. If the color of the exhaust is bluish, then it indicates the burning of lubricating oil in the engine. So clear exhaust is an indication that the combustion is perfect. Next, engine operating conditions may be indicated by the color of the exhaust smoke. Black smoke could indicate an overloaded engine. So it was also explained in the previous question. Next, restricted air intake to a diesel engine may result in engine failing to reach the rated speed. So when the air intake on the engine is restricted, automatically the fuel will not burn properly. Hence, what power generated by the engine will be less. When power generated by the engine is less, it may be possible that it will fail to reach the rated speed at a lower condition. Okay, with regards to diesel engine crankcase explosion, the most violent is first secondary explosion or the second primary explosion. So the answer should be the primary explosion. So the primary explosion is the most violent one. Okay, that's it for our presentation. So this is the end of troubleshooting number 2. So I will create another video for troubleshooting next time. So just comment down below or just message me if you have any more questions or clarifications and suggestions. So that's it for today. Thank you very much. So God bless and goodbye.